All right, I think we've got everybody in. There's still a few guys joining. All right, hi guys, and welcome to today's webinar, the webinar on sheet metal. Thank you guys for joining us this Thursday afternoon again. So just a few rules or just a few guidelines before we start this webinar. Just get this thing. Okay, so just the guidelines for this webinar. We just make sure your cameras is off, just so that we can see the host presenters, the guys that are presenting. So just the introduction. My name is Rudolf van den Berg. I'm an application engineer here at MiCAT Systems down in Cape Town. So I'm doing the introduction for today, and yeah. So we're going to record this webinar and also send you this after the webinar. Just make sure the recording of the webinar is a WeTransfer link, and that WeTransfer link is only valid for 7 days. So be sure to download it in the next 7 days. So yeah, and all the previous webinars is available. You must just go email us to request a link to that, please. All right. And also just reach out and learn. Basically, we are in the process of doing online training. We're just setting up a few stuff, testing a few stuff, especially for the sheet metal stuff. We are busy with advanced sheet metal that we want to host. So if you guys are interested in that, be sure to tune in. We will keep you updated and posted. Right, and then just keep an eye on our LinkedIn page, our web page, YouTube channels, Facebook channels, Instagram, and also our MiCAT Minute every day. We share a tip and trick every day, so be sure to check that out. Okay, so let's jump right into it. Today's presenters is going to be Raymond Steyn. He's application engineer, also here down in Cape Town, and Kieran Barnard. He's application engineer in Durban. Right, so they will take you through today's webinar. Thank you so much, guys, and hope you guys enjoy it. Kieran, I'm handing it over to you now.
Afternoon, guys. Rudolf, can you see my screen?
Not yet.
Okay.
Just share your screen.
Perfect. Can you see it now?
It's there. Perfect. Thank you.
Cool. Thanks so much for that introduction. So today, like we mentioned, we are going to take you through some sheet metal functionality. There's a lot of useful features within sheet metal, so we're going to have a look at some of those. So with regards to the agenda, I'll be taking you through the introduction to sheet metal. I'll be taking you through sheet metal design, which will be the parts and drawing aspects. My colleague Raymond will be taking you through the tips and tricks. And then after that, we'll have a little Q&A session, and we might have a poll at the end. I'll just confirm with Rudolf. Okay, so let's just go to the next slide. So I'm just busy admitting people. Perfect, so let's have a look at introduction to sheet metal. So with regards to the sheet metal, once you create a sheet metal component, you'll notice in your design tree that there's a certain amount of features that will automatically pop up. So those will be folders, those will be your flat pattern. So let's quickly dive into it and have a look. So from the first folder at the top, you'll see it's the overall part settings. So in this overall part settings, this is once you, before you've created your sheet metal component, or rather say, you can change the sheet metal parameters such as your thickness, your bend radius. You can select gauge tables, and you can select various sheet metal settings or sheet metal parameters in that regard. When creating multiple sheet metal bodies, what you can do then is you'll see in the solid body settings, you'll have multiple subfolders under the sheet metal folder, and from there you can actually individually change your sheet metal parameters such as your gauge tables and thicknesses from there. So you can have one sheet metal component with various gauges of steel or various thicknesses or bend parameters. Then again, we're just going to look at gauge tables. So I'm not going to go too much in detail with gauge tables, as my colleague Raymond will just have a look through gauge tables with you guys. We're going to look at feature settings. So feature settings, That will encompass, we can add in some depth, we can add in material direction, and we can add in extrusion length. So that's what I meant by depth. From there, we can also override sheet metal parameters, and we can, we can also override sheet metal parameters and your bend radiuses. We can also change our K factors, stuff like that. Then again, SolidWorks, to create the flat patterns, it needs to create individual bends. So if I create a complex part, I'll have more base bend lines. And if I create a simple part like this one that I use, for example, there are only 2 bends. Finally, there's just the flat pattern folder. This will always pop up the moment you start creating sheet metal components. And under this, there will be the solid body flat pattern. So obviously, the more bodies you create with sheet metal, the more flat patterns you'll have. Okay, let's go to the next slide. So from here, I just want to take you through verification of rebuild. So verification on rebuild is an excellent setting to have, especially when you're designing a sheet metal. It allows you to ensure that when you want to go at the end of your design and create your flat pattern, you don't run into any issues. What verification on rebuild does is it performs a thorough evaluation of the model during rebuild. And what it also does is it checks every new or changed feature against existing walls or existing faces or edges. So that just means that when I actually create the features, I don't have overlapping bend lines, I don't have overlapping edge flanges, stuff like that. Okay. So let me take you to my second section. So what we're going to look under here is your sheet metal design side. So we're going to look at mainly your parts for this section. So as you can see on the screen in front of you, there's a very simple sheet metal component. I created the simple sheet metal component because it allowed me to show all the features that I use. So it uses a multitude of features to create this. And we are actually going to create a component similar to this in SolidWorks in a moment. So let's just have a look at some of those features that I was talking about that we use to create the components. So you'll see we created a base flange. So I created a base flange. Base flange features are sketch driven. In your base flange, again, like I mentioned earlier, in the feature settings, you can change your sheet metal parameters. You can add in custom parameters. You can override parameters and stuff like that. But we'll have a look at that when we get there. Edge flange features, this you require an existing sheet metal body. It is also a sketch-driven parameter or sketch-driven feature, but we need an existing sheet metal body because we need to select an edge. So if you can see, there's a blue dotted line. Let me just get my laser here. You can see we selected that edge to create that feature. There are also various options within the edge flange, so we'll also just explore some of those at a later stage when we do the design. Lastly, or for the slide, we have the hem features. So hem features are often used just to add structural rigidity into your components. So from there, what we're going to do is maybe just add in a hem, make some alterations, maybe make some alterations or rather, change the components out a bit, and we can have a look. Okay. Before I carry on, I just want to mention one more thing, and we are going to create a mitter flange. So a mitter flange is also a sketch-driven feature. The feature runs with, like I mentioned, it's a mixture of an edge flange and a base flange. It is a sketch-driven feature. However, you do need a sheet metal component. So when I go and create my design, we'll have a look quick. So let's quickly switch to SolidWorks and start the design. So as you can see, I've already gone ahead and just done a predefined sketch. From here, I'm going to select base flange. Now, what I wanted to just show you was when I actually go to my, sorry, I just want to close it. Okay, when I actually go to my tabs at the top, you'll notice that there's no sheet metal tab. So I did this on purpose, just so I can show you how to find the sheet metal tab. So what you do is you right click on any of these tabs and then you just click sheet metal. So from there, we're going to select the sheet metal, select base flange, and we're just going to go ahead and select our sketch. Okay. What I'm then going to do is just select my parameters as mid-plane, and we'll just go make that 100 mil depth. So like I mentioned earlier, we have sheet metal parameters. So this would be my sheet metal thickness. This is my bend radius. We can also play with the direction, so we can have material on the inside or outside of the sketch. In this example, materials on the outside of the sketch, we can switch that around. But for the sake of this example, we're going to use something called a gauge table. So for gauge tables, just reorientate our video quick. Perfect. So for gauge tables, I'm going to select our sampled steel table. So again, like I mentioned, Raymond will take you through gauge tables in a bit in his section. Okay. And you'll see now when I select gauge tables, it actually now gives me an example, gives me options. So it will automatically select the 3 gauge. That's just the first on the list. We are going to go ahead and create the design with a 16mm gauge. I'm then just going to reverse my direction to make sure that my material is on the inside. And like I mentioned, you're always able to override the dimensions. So from here, we can override the thickness, change it if you don't want, if gauge 16 is incorrect here, for example. And we have various bend options or bend radiuses that we can select from. Okay, so we can do this then. Again, override it, and you can override your bend allowance. Okay. So from there, we've now successfully created our base flange feature. What I want to show you is that it's got its 2 little base bends in there. What we're also going to do is just have a look at maybe just quickly reviewing the flat pattern. So there's 2 ways. Right-clicking on a face and saying toggle display will give you just an indication of what it looks like, or you could right-click and say flatten. It will actually flatten the component. From here, we can just unflatten from the icon at the top, or what we could do is unsuppress and suppress it from here. Okay. So let's go ahead and add the edge flange feature. So what I'm going to do is make sure that when I select it, it says flange parameters. So remember when I mentioned it's we need to select an edge. Let's go ahead and select these 3 edges. Okay. From selecting the edges, I now realize, okay, I want it to be 10mm thick or 10mm high rather. And I want my material to be on the inside. So here's different flange positions. So if I can just reorientate for you, that you can see better. Sorry, there we go. You'll see there's different flange positions. I can make the material on the outside, have it at a bit of an offset, and various other options. So from here, I'm going to then just say, okay, now I want to just show you something. So the moment you're gonna notice that there's some excess material. Now, what I see often while providing support is that we actually see customers would create the sketch and actually do the cutout. Now, there's nothing wrong with doing that, but there is a much easier way to actually get the correct bend geometry in the ends. And how we do that is just by editing the edge flange feature. So once you right click, say edit, all we're going to do is it's a simple checkbox called trim side bends. Once you select OK, you'll notice the excess material is gone. Okay. What we're now going to look at is creating hems. So let's just add in a hem or 2. So from here, in my sheet metal tab, I'm going to select hem, and we can just go ahead and select our 2 necessary edges. Okay. I now realize that I would like my hems on the inside, and they're facing the wrong direction, so I can just select on the specific hems and edit the direction. Okay. Now, when I said there were multiple options of hems, we have a few here. So here's closed, which is the one we will be using. There are open, teardrop, and there are rolled hems. So for this example, we're just going to use the closed option, and we are going to create it as an 8mm length. Okay. So from here, we can see how simple it was just to create those simple components. So next, we're going to create that miter flange that I spoke about. So miter flanges are, again, like I mentioned, sketch driven. So let's create our sketch. I'm going to just select my top plane, control and drag it. And for my second reference, just select the right edge. Okay. From there, I'm just going to go ahead and create the sketch. So on the plane and select our line. I'm then just going to head and draw my flange shape. So we'll do it like that. And we can just reorientate and fix our sketch quick. Okay. From here, we're just going to add in our geometry. So we want a 135 angle. We want it to be 10mm depth. Sorry, that's 100. Let's just redo that. We would like this dimension here to be also 10mm. And we would like our overall length here to be 5. Yeah. What I can then do is just go to my sheet metal once I'm done with my drawing my sketch, select mid-flange, and you now notice it will automatically just create a pre-selection, or it will automatically draw from that line. What I'm going to use now is something called tangent propagate, because we'd like this mid-flange to run along the entire edge of the model. So by simply clicking this tangent propagate option that pops up, you'll see we have our edge flange, or mid-flange rather. Okay. What I'm then just going to go ahead and do is we can just create our flat pattern. Okay. You'll see as well, there are dotted lines and solid lines. So these are just variations. It just shows you which lines are up and which lines are down. Okay. So just one or two little tips and tricks quick. We're going to now just create a cutout. We're just going to create it on this face. And from here, we can just draw it. We've decided that we need this little cutout for clearance, for example. And from here, we can just add in dimensions. So we'll just select our origin. Cool. Sorry, let's just add that to 10, sorry. And then from there, we can just add an overall dimension of 20. Okay. What I want to do now is just show you that when you now create extrude cuts, especially with sheet metal, it now gives you an option called link to thickness. So what link to thickness does is, say now I go ahead and change my gauge steel thickness, it will automatically update, and the cutout, you'll always have a cutout that is correct. Okay. Next, we're going to create one more cutout quick. Again, we're going to create a simple shape, so a corner rectangle. We'll draw from this face, and we'll just do a box. From here, what I'm going to do is just give it geometry. We can give that the 5 mm dimension and the overall length of 10 mm. So you'll see we're not going to define the length as it's not necessary because we have a predefined cut length. Okay. Sorry, I'm going to have to do it from here. Cool. From there, as we do the cutout, we're going to then just say blind. That's fine. And we're going to uncheck link to thickness. We would like it to cut at 12 mm distance. And I'm going to uncheck normal cuts. Why am I unchecking normal cuts? I just want to show you the difference what normal cut does. Okay. So you'll see now what normal cut does is when I go now and create my flat pattern, you'll see now it gives me a flat pattern, and this face is at an angle. This doesn't work well for production purposes when you send out your component for manufacturing, especially with the plasma cuts and laser cutting. You're going to struggle with that face. So it would probably have to be redrawn. Or what I've also noticed is we actually get individuals or CAD designers who actually go and do a cutout at an angle. That's not necessary. By simply just editing your feature and saying normal cut, it will automatically create a correct, or rather the correct flat pattern. So let me quickly just show you. And you'll see our flat pattern is perpendicular to our face. Perfect. Okay. Next in the design process, after consulting with some other departments, we realized, okay, we need some clearance on this specific flange. So there's a few ways you could go about doing it. You could create a sketch and do a cutout, but that's not necessary. It's much easier to do it this way, where you just edit your edge flange feature, make sure that you select the right edge. So I'm selecting edge 1 and say edit edge flange. From here, just select your sketch, drag it. We know from there that I need a 20 mm clearance. And we can just say, okay. Okay. Sorry, let's just get out of this quick. Oh, there it is. Sorry. And we can just click finish. Okay. You'll see now it automatically updates the edge. or the edge flange, but notice the hem also updates with it, which is the standard behavior. This is what we're expecting, and it makes your life a lot easier. We then also spoke to our designers and our consultants, and they mentioned to us that maybe this edge flange feature must stay, but this hem over here needs to drop down a bit. So how do I do that? Well, the same way we just did the edge flange. By selecting the hem feature, right-clicking and saying edit, we can then just make sure that we're selecting our correct edge. So for this example, edge 2, and you'll notice it just gives me a little line. From there, we know from our consultant that we need a 10 mil clearance. Okay, and we can just think, so, okay, so sorry, my option keeps on popping up on that screen. So we can just say finish, and you will see that your hem updates. Okay, perfect. So I'm going to quickly just jump us back to our PowerPoint. Okay, so next we're going to look at something called the fold and unfold feature. So within the fold and unfold feature, it allows you to add in geometry onto flat patterns, and we will have a look at sketched bends. So let me go ahead and just switch back to SolidWorks. Okay, so from our fold and unfold feature, what we'd like to do is we'd like to add in actually a cutout over here for cabling. And what I see often is we will see that we create a flat pattern. From there, we create a sketch on the face, and we create a, let's just make that one a bit smaller. And we create a cutout. Now, that's fine, and it works, but now the issue comes with when I actually go and unflatten it. My feature completely disappears. Why is that? Why? Well, what we did was we followed the wrong workflow. So the correct workflow is needed when creating features on your flat pattern that you would like to be able to use in your bend component. So how do we do this? We use the unfold feature first. So you'll see in your sheet metal tab, there's unfold. From here, I select just a fixed face, and I select, so there's two options. I can say collect all bends, and it will give me my entire flat pattern. But for our example, we don't need that. We just need one specific bend to be unfolded. So let's unfold that one. And from here, I'm just going to create another sketch. We'll create it on the same face, and it'll be a little cutout, for example. So we'll just go ahead and do the cutout. And from here, we can do the extrude cut. Okay, again, I'll just check link to thickness and say, okay. What we now need to do is we need to just create that fold feature back. So I again just go to my sheet metal tab, select fold, fixed face, and then your second selection needs to be your bend. And you'll see now that it pulls through my cutout to my bent component. So that's the first thing we're going to look at. And then the second thing we're going to look at is sketched bends. So let's just quickly add in a sketch bend. So I'm going to create a sketch on this face. Again, we'll create a corner rectangle. We will quickly give it a dimension here. Sorry, apologies. Let's just give it a height first of 50. And we'll give it a thickness of 20 mm. Yep. We then just need to give it a dimension on the side just to constrain it. So from this edge, I know I need 80 mm. Okay. Do a little bit less, sorry. Let's do 70 mm. Perfect. So from there, again, sheet metal, base flange, and you'll see it'll automatically pull through the gauge material that I was using and the thickness, and all I can do is just click OK. So let's quickly create that sketch bend. So this component, we need to create a tab. Now this tab needs to slot into another component, for example, and we have a specific height we need it from. So I'm going to just create a sketch on the face and draw one line. Okay. We know that that tab at the top that we're going to bend 90 degrees needs to be a height of 25 millimeters from the top. So we need the top face of this bend to be 25 millimeters. So all I do is I draw that line, say sheet metal, sketch bend. So what I just want to show you is if you select at the top or above the line, it'll bend your entire component that way. Or if I select below the line, it'll bend the entire component that way. It's exactly the same, nothing changes, it's just your orientation. Okay, then you'll see, yeah, there's a few options. So if I select my first option, my bend line is in the center. So you'll see it's exactly in the center of my bend line. I can select material on the inside. That'll give us our required 25 mil height. Or we can material on the outside or material at an offset. It's not at an offset, sorry, bend on the outside. So it's completely up to your application. So from there, material on the inside, and we are going to say, okay. So I think now is a good time for us to maybe just have a look at our flat pattern. So in terms of a sheet metal component, this is a rather complex one. I wouldn't say it's very complex to design, but to manufacture, I think it could be quite challenging. But it's just to show you how, no matter how complicated you can make, you want to make things, SolidWorks will be able to handle it. Okay. So let me swap back to my PowerPoint slide quick. And from here, there's just two features that I'm going to show you that we are not going to include in our component, but it's tab and slot. So tab and slot is it's a nice little feature in sheet metal. With two selections, we can actually create the tab and slot features. So the first selection was this line here. So you'll see it's a purple blue line. And the second selection was this line, this bottom face. And you'll see on my two separate components, what it does is it creates a tab and it creates a slot feature. This is especially useful when designing. It's quite useful that you can do it from a multi-body part environment, or you could also do it in an assembly environment where instead of doing multi-body parts, you're in an assembly and it's separate parts. Okay. Next, we're going to have a look at loft features. So loft features are quite popular in the HVAC industry. All there are two sketches, generally a square to round or various square shapes or octagons, or it's just between two sketches, and it will actually automatically generate the geometry. So you'll see for these two examples here, I had added in a few nice examples. So what I want to mention to you is there's two main types of lofts within the loft feature. There is a bend to loft, which is like the one I'm hovering over now. It will actually give you the flat pattern, and it does give you all the bending instructions on the flat pattern. The form feature does exactly the same. However, it retains the formed look. So it doesn't look like it's been bent, but rather formed over a mold, for example. And it does still give us bend instructions. However, it does come with a warning where it says it's not that accurate. Just the most important things to remember with loft features is you'll see these lines here, these little construction lines. Those are very important, where what you need to do is you need gaps. So SolidWorks needs a point where it can start unfolding that component from. If you do not have gaps, that feature will fail. All right. So that brings me to sheet metal drawings. So sheet metal drawings as well, probably the main driving factor for using sheet metal is Weld cut lists and your flat pattern. So let's quickly have a look at the Weld cut list. So Weld cut list is a table that you can add in onto your drawings. From there, what we can do is link it to properties as you see on your right-hand side. So some of these properties are, for example, your bounding box area, your bends, amount of bends allowance, materials, mass, and bend radius. These are all things that are very useful, especially for the production environment. And in this, we will quickly have a look at how to create those. So from here, we're going to go back to our sheet metal component, and we are going to quickly create a drawing. I've already just gone and created a drawing with some views already in place. Okay. From here, I'll just change the color. And what we need to do now is add in our Weld cut list. So our Weld cut list can be added in by simply just going to annotations, tables, Weld cut list. So I'll quickly run through that step again. So annotations, tables, Weld cut list. Once I select my view, you'll see it give me a few options here. We're just going to run with our standard table template, and we're going to say, okay. So you'll see at the moment I have a cut list table, but it doesn't really give me much information. So I would like to add it to some of my custom properties like I showed you on the previous slide. So let's quickly open our components as well. So we'll just quickly jump between the, there we go. Let's go to our components. And from here, I just want to show you where to find your cut list properties. So under your cut list folder at the top, once you right click, you can click cut list properties and just drag it across, and you'll see from here, it's all cut list properties. And these are standardly set. You can also add in a few various other options. However, we are just going to use the standard for now. So let me just jump back to my drawing. You'll now see that we actually want to link this table to some of those properties. How do we do that? Simple. Description at the moment, it says sheet. We can change the description, but for us at the moment, it's not that important. So let's go ahead and select on the C. So you'll see on the top of your column, you just select on your table first, then select the C, for example, yeah. And you will see once I go to my cut list item properties, there are those options. So what we like to do there is add in our sheet metal thickness. And for length, we can change that one to our mass. Okay. So those are just some of the examples of things you can do with your cut list as well. Once you create a cut list, it's not necessary to constantly create new, every single time you want to create a cut list to create a new table the whole time. What you can do is just right click on anywhere on your table and say save as, and it will allow you to automatically save your table, your template. Okay. Next, we're going to have a look at, let's quickly switch back to the PowerPoint. So next we're going to have a look at our flat pattern. So a flat pattern is probably the driving factor why you would design a sheet metal. You need the flat pattern for manufacturing purposes, and it just makes your life so much easier when SolidWorks generates your flat pattern for you. So let's go back to our model. And from here on our second sheet, we can just go ahead and add in our flat pattern. Let's have a look here. Let's see. Okay, it's not giving me my flat pattern. That's fine. Let's just drag it in again. All right, so within the configurations, what I'm going to do is just switch to just a backup drawing, just so that it allows me just to show that part. We can just switch to. Okay, from here, you can just create that drawing. And what I want to show you is just the flat pattern again. So let's just get rid of our flat pattern. Okay, so we can just go ahead and select our part 1, for example. Pull in our flat pattern. And you'll see we have various options available from our, let's just exit our projected view. Sorry. Let's then go ahead and I just want to change our scale. We can use our custom scale. We can change it to a 1:1. And from there, we can notice now that you see all your bend lines on your actual drawing or on your flat pattern. So some of these bend lines, like this one, for example, is interfering with my components, or it doesn't look exactly very pleasing to the eye. So one way we can do that is just by simply clicking on the dimension, adding in a leader, and then just dragging and dropping it. Okay, that's one way. The alternative way would be, especially if you're designing very complicated pieces, is just to go to your annotations, tables, say bend table, and select your view. From there, we can just say okay, and it will give us a bend table. So that's all from my side at the moment. I'm going to hand over to my colleague Rudolf. Sorry, I apologize, to Raymond, and he's going to take you through tips and tricks. Raymond.
Yes, I'll just be setting it up on my side.
Sure.
There we go. Well, welcome everyone. Good afternoon. Thank you so much for those in attendance today and actually making this series possible. Just from my side, I'd just like to thank the PCAT technical team for giving me this opportunity alongside Kieran to just share some insight. So as Kieran mentioned, what we'll be looking in specifically for the second session is some general tips and tricks. And I'll basically just be adding to what Kieran has demonstrated and specifically just touching base on some of the advanced options and features and some settings that exist within them. So moving forward, I'll ease us into this by applying some corner treatments. So the first thing I'd just like to point out over here is that corner treatments can basically be applied and added to the folded sheet metal body. These treatments will affect the flat pattern, as you guys might have seen within Kieran's session. Just a very quick demonstration. Within the sheet metal tab, you guys will notice under the corners, if I click this down, there's quite a host of features that can create exactly as the images indicate. I can close or extend my edges or gaps, and then actually add some relief options where there's some sort of pinching effect that takes place. And then as you guys can see in the flat, I've got a very distinct snit over there. That little snit. We do have some options to obviously show or hide that in my flat if need be. Moving forward, you guys will, I'll be jumping into SolidWorks and demonstrating this in a quick moment, but I'll be looking specifically at the corner relief feature. Now guys, this is a very nice feature to definitely not forget about. You guys will notice that we've got quite a few default options available, like the rectangular, the circular, the round option. I think these are mostly or broadly used. What I'd like to just point your attention to specifically this afternoon would be the full round and suitcase options. So I found that these two options are very specific to specific designs or workflows. You don't encounter these kind of situations in your day-to-day, but definitely something to check out and save for a rainy day. Don't forget about them. So before we jump into that, please be aware that something like the O-Brown option has got a certain set of dimensions to actually control the length or width of that actual cut slot being put in, which is good to know of. It's not something you just need to add and say, okay, you do have some flexibility around it. Before we jump in, I'd just like to point out, guys, that the full round and the suitcase option, as I'll be demonstrating in a moment, does require 3 blended corners. So basically 3 corners blending into or 3 edges blending into a single corner. And then the suitcase, just to point out, has got some options available as to what I want to do with that gap or actual cut snit being presented. So as you guys can see, the default option over here, bottom left, basically just gives us a nice finish. The extended gap option is a good one to know of, especially if you want to bring in that gap a bit closer. And then you fill in some gap if I want to go the negative way or the other direction. So let's quickly jump into SolidWorks and actually have a look at all of this. I'll be making use of this model just for presentation purpose. And as Kieran demonstrated, you usually find this kind of situation when we have something like a base flange and I actually go and use and add a edged flange. So as you guys notice, I've got very distinct 3 edges coming into one corner. So let's just go and check out the options mentioned. So I'll go ahead and click on the corner relief. And as you guys will notice, no corner relief is currently already in play over here. The only feature I've added is the edge flange that does have some sort of relief option available. I'm just going to further that. So the first thing I need to do is select the 3 bend corner option. And I'm just going to click on collect all corners. As you guys see, this will then automatically pick up all the available corners. And for this specific workflow, for this specific situation, you'll notice the full round and suitcase coming alive. Just to show you what each does. As it said, the full round option basically starts at the vertex and then makes its way or follows the actual opposing edge till it meets the bottom side over there. So it's basically just a nice little closed loft. And then the suitcase option, on the other hand, gives me just a bit more flexibility as to what I can do with this actual cut or extend over there. So the default is exactly as it sits. Then I've got the option over here stating extend the gap, and we can actually give it a nice distance. I'm just going to give that 3 for argument's sake, so you guys can see exactly what took place. And last but not least, we've got this option over here, the fill in some gap option. And as you guys can see, I can now actually go the other way if need be. As mentioned, guys, this is a very specific feature. It's not something you encounter every day, but I do believe it has its place. Specifically, seldomly outside of the sheet metal world, sheet metal mythology is used, and I'm pretty sure this can aid industrial designers, for example. So just to show you what we've acquired, if we actually go and flatten this, you guys will now see what is the effect. Remember, I do not see the actual cut because in my relief feature, I've gone to actually added the fill in some gaps. So I'll just hit that option just to show you guys. So you can clearly see the result. The actual cut is added to my flat pattern. So no need to worry about what the flat's going to look like. All is still good. Just jump back into PowerPoint. And next up, guys, I'll be introducing you to forming tools, specifically for those who has not had a look at them before. Definitely a great option, guys, to consider for creating custom punch or press tools for seldomly advanced part design, the quick and easy way. So this is something I'd really like the guys that hasn't gone and checked this out to please go and give it a look. It's not as daunting as it seems. I must say this can really aid any big design office in quickly and easily creating complex shapes. So the first thing I'd like to start off with is stating that there are two methods for creating forming tools. You guys will notice we've got the default forming tool file type. So this is a very specific file type that you save your SolidWorks part in. And basically you save it in that file type and store it in absolutely any folder on your PC. This forming tool functionality is then based on the actual file extension. So good to know, just be aware of that. Then secondly, we can create a SolidWorks normal part and actually save it in a folder specifically marked as your forming tools folder. So as you guys can see over here, as the image indicate, I can either create a simple part and actually save it out as a forming tool, which will then pull through the forming tool functionality. Or you can actually go and save it as a SolidWorks part, a normal part, bring it into your design library, and whichever folder hosts that tool, you just need to right click on it and make sure you hit the option to state that that is your forming tools folder. Those are the options that exist. Whichever gets the job done quicker for you, I'd recommend to go and explore. Just a second addition or just some insight as to how SolidWorks actually links this information of files would be to understand where the forming tool file location actually resides within your options or settings. So in your settings, this can be found through tools, your system options, file locations. There's a very distinct design library location, and this will enable you to go and add custom locations. For example, if it's on your server, you're more than welcome to go and add it. With this method for the design library, you will need to go and right click on the folder that you've added to your design library and hit the option to mark that as your forming tools folder. So then the default location for SolidWorks, guys, rests within your PC under the C program data location. And the reason I've put this in is to just show you that there are already a host of default forming tools available. Great to go and edit, make them your own, and basically just use them. This advantage, or the advantage of this, is obviously your file location side has already been taken care of. So please get in touch if you have had a look at this and struggle with the linking. We can definitely sort you out. Just to emphasize the easy or how easily it really is, you guys will notice, create a simple SolidWorks part, cut and extrude. Hit the option within your sheet metal tab called Forming Tools Feature. I'll set that up in a moment, show you guys what that's all about. Or you can obviously save it as that forming tool file type. Needless to say, you can link it with a simple drag and drop operation, create pretty cool press and punch tools. You don't have to keep this very, how can I say, simple, guys. I've seen some pretty advanced stuff coming from this method. So the last thing I want to show regarding forming tools is the ability to actually show or hide them in your flat patterns, which is a great advantage. You don't have to be forced to leave them in. I know cleaning up your DXF can aid a lot of design offices. The way we get this going is once we've added the forming tool feature, right click, edit, and within it, we've got a flat pattern visibility session or section. Very nice to actually be aware of. So let's quickly jump into SolidWorks and I'll show you guys what that is all about. So I'll start off by creating this very simple SolidWorks part, nothing fancy or no fireworks yet, just to show you guys. So very simple very basic part that I've created. And what I'm going to do now is hit the sheet metal tab and quickly create this forming tool. So in the sheet metal tab, forming tool, very, very straightforward stuff. The stopping face is in this case going to be this bottom one. And this is basically just to indicate where the actual tool must stop pressing when it meets the target body. For the faces to remove, I'm just going to go ahead and select the top face for preparation or for presenting purposes, but please be aware you don't necessarily have to remove any faces if you just want a punch that doesn't cut any material away. Under the insertion point or insertion point, guys, we can actually create alternative points, which can then be used as adding or in the adding process. I'll get to that in a second. I'll just go ahead and say, okay. And over here, guys, I'll just rebuild the part. Go to File, Save As, and as demonstrated or mentioned, go and save your tool out as a forming tool part. This will then obviously bring in or pull through the forming tool functionality. Save it absolutely anywhere. Go and link that file location on your PC within SolidWorks so you can start using or getting the magic going. I'll quickly demonstrate this forming tool that I just created, just to make sure I saved it. Cool. From here, guys, you'll notice I've added quite a few other forming tools just to show you what SolidWorks has available by default. Definitely a lot of options available, should get the job done. If I go to this clean face, as you guys can see, I've got my forming tools folder over there that's already been marked as the forming tools folder. And this is the defaults that SolidWorks has available. From here, guys, I'm just going to drag and drop. So there's the one I just created. Simple drag and drop. And you guys see what it does. So just to take you through this property manager, we've got two tabs, a type and a position. If I hit the option to flip the tool, you'll notice what it does. Obviously, changing the orientation won't help much in this case, but I'd just like to show you guys we can configure these forming tools as well to accommodate different sizes. The link to form tool is always selected by default, and as it states, or very self-explanatory, this creates a reference back to the original tool. So if you ever change any dimension within the tool, you know that the sheet metal parameters will update as expected. Definitely not something to go tamper with if you're not aware of the full effect. For the position is where I actually set how many instances I want, and this is done through simple SolidWorks sketch points. So wherever there's a point, you guys will see what it does. I'll go ahead and say, okay. And as you guys can now clearly see, it can really save me a lot of time. I can just imagine the kind of nonsense you go through to try and get these results manually or in a different method. So please go and check out forming tools, definitely worthy of your time. To come to the flat real quick, if we flatten them, we don't want to see the actual form tool, or in some cases you don't want to see them. You'd rather just see some form of sketch lines to indicate their position for cutting or manufacturing procedures. So the way you do that, guys, is to go to your countersink actual forming tool feature, edit, and you just need to go and access the flat pattern visibility. So override the actual settings and just deselect the option to show the punch. We can show some centers and some profiles instead. So you guys can clearly see what's the result. Very nice tip to definitely go and make use of, can really speed up your designs. So just to move on, let's jump onto the PowerPoint again. Next up, we got what I like to call design tables for sheet metal. And what I'm specifically referring to is what we call gauge tables, guys. Definitely something to go and have a look at. As Kieran mentioned, it's very easy to really get this going or select the default SolidWorks gauge tables. What I'll be showing you now is some of the back-end info. So I'll start off by explaining that there are two types of gauge tables. The simple table, which basically hosts your K factor, your gauge values, your gauge thicknesses, and available radii as selection types. The gauge table bend table combination is a bit more of an advanced step up from that, due to the fact that you use basically your gauge table and bend table in a single one. And basically, guys, in a nutshell, this combines any bend allowing or bend deducting calculations to be done to select or have you select simple gauges. So I'll jump into SolidWorks and Excel in a moment, show you guys what this is all about. When you go and click on the option Kieran mentioned, use gauge table over here, you'll notice there's a host of defaults, and I'll get to that in a second, but please be aware where to find them. You'll notice I've tried to indicate as good as possible where your your gauge and bend table combinations lie, as you guys can see over there, and your normal gauge tables. So please don't get a fright when you open them. You're not seeing what you're expecting. Be aware that there are default or different defaults available. Moving on, guys, you'll notice that you can find the actual gauge tables by default in File Explorer. That's on your own PC or on your C drive. Following that location, you should find the SolidWorks default. So basically, to create your own custom table, I would recommend going to that location, opening them, and making use or just applying your custom values, save it as a different name, and be sure to go link it in this SolidWorks file location. So there's a very specific file location setting. As you guys can see over here, I've gone and added a default one in the file location to go and find my custom webinar gauge table. So before we jump into SolidWorks, for me to demonstrate, I'd just like to emphasize, guys, that if you're doing a lot of in-house manufacturing specific to sheet metal, gauge tables can really save you a lot of time when it comes to minor edits. Definitely something to not skip, especially if you're doing a lot of editing. So let's have a look quick in SolidWorks. I'll just open Explorer quick, and I'd just like to show you guys where to actually find the SolidWorks bend tables. So as I mentioned, in this location, you can all see what is available. So go and use these tables, customize them, and make them your own. Within Excel, guys, I've gone and opened one of them. So this is just your good old-fashioned Excel. Before I jump into SolidWorks, I'll just quickly make an edit and show you guys what is possible. So I'm going to just copy this and paste this, give it a new name. So I'll just call this new. Give it another thickness. Let's make that 3.5. Let's maybe add a radius, extra radius. And I'll just copy these values. Personally, I'm not a fan of Excel, guys, but I'm sure one guy in your office does know his way around Excel. From here, I'll just go ahead and save this file. And let's jump into SolidWorks and see how we can actually apply the edits. So I'll just save and close Excel. It is necessary for Excel to be closed to reflect your changes. Please be aware of that, guys. So with the actual gauge table being set up and created in the background, I've already gone and linked it in my options. So tools, options, file locations, as I mentioned, go and link it there. And to get this going, your sheet metal folder hosts all the predefined parameters. If we go into this, you'll notice I've got my webinar K-factor table available. And if I select it now, I'll say yes. Just give it a moment to load. You guys will see the new gauge that I've created is available alongside any radius values that I've added or any other parameters. Definitely a good way to get a quick design going or editing going. This is great, guys, especially if you're dealing with your own in-house parameters or your own custom designed machines. Definitely something to not overlook. Going back to PowerPoint, I'd just like to quickly discuss some of the convert to sheet metal options. So this is also something broadly used. I'll be diving a bit deeper into an advanced workflow, how to create multi-body sheet metal parts using this feature specifically. So this is a great option to explore, guys, for the guys doing very large sheet metal design, or your components are too big to place on one sheet and needs to be assembled and welded afterwards. This workflow or procedure will produce two flat patterns that I can show on a single part or drawing, and that's a good benefit to be aware of. You can, on top of this, just to maybe add it for interest's sake, is you can go and assemble these components for later or for further use, for example, a bill of material, etc., etc. So definitely you've got a lot of options available from this. Before I jump in, some additional options that can also create, or some additional features that can create a multi-body sheet metal parts as well, would be the intersect and split feature. So for the guys dabbling with a bit of advanced part modeling, you guys will have encountered these. Just like to point out, gentlemen, ladies and gents, that there are some settings available within these features to either remove the original body or actually create or remove any of the other features. Just to show you guys, the intersect has got the consume surfaces and the split has got the consume cut bodies. And I'll show you where this comes in a moment. The convert to sheet metal has this keep body, which we probably are all aware of. Remember, the aim of this game is to acquire 2 sheet metal bodies at the end of the day. I'll be then moving over to the drawing side of things and show you guys how to add multiple flat pattern drawings or flat pattern views on your drawing. Let's quickly jump into SolidWorks and just show you what this is all about. So from here, you will clearly notice, or just to show you guys, I've gone in, cut and extrude this. Nothing really fancy, as you guys can see. Basic loft, basic cuts, basic extrudes. And then I've gone and opted for the convert to sheet metal feature. So just to show you, on the first convert to sheet metal feature in my tree, I've gone and selected the left face and all the abiding edges on the left-hand side. I very specifically hit the option to keep the original body because I need to reproduce this as a second stage to acquire the second flat pattern. So nothing fancy right there. I've just converted the half, and to prove this to you, you guys will see that I've clearly got half a sheet metal body, and I've got the original Parasolid or 3D model also available. Then I've gone and added a second convert to sheet metal feature and selected everything on the right side with the accommodating edges, with the rib edges also being selected. And the magic happens if you deselect the key body at the second convert stage, and that leaves you with a nice two-body sheet metal component, as you guys can see. So multi-bodies that's created over there. Before I move on, guys, I'll just quickly jump into the drawing and show you guys how I've got these flat patterns in. I'll just change my gauge table over there. So as mentioned, there's quite a few other workflows available. I've seen some pretty interesting workflows for multi-body sheet metal design. I'd just like to ensure you guys that you've got quite a bit of flexibility regarding these options. There's no really a wrong or right way. There's really only the way that's going to accommodate your design intent. So to quickly show you guys, if I need to bring in multiple flat patterns, the first thing you're going to notice is that no flat pattern will appear in your view palette, as you'll see. And this can be a fright or can be quite a fright for some. No need to fear. I'll quickly show you guys how to get multiple flat patterns in. You hit this option stating model view. I select the part, and hitting this arrow stating next, I'm actually able to go and select certain bodies. So this throws me back into the part environment, and I'll just select the second body and say, okay. From here, guys, you'll notice the flat pattern view now being available. And once I hit it, place, just do a quick rebuild, and you guys will now clearly see what is actually created. I've got 2 flat patterns that's added, and this is not limited to the 2 I have. You can create as many as you need. I'll just change the scale here real quick. And there we go. Let's quickly jump back into PowerPoint, finish this off. So staying in the drawing side of things, guys, I thought it'd be a good sweetener just to show you guys what is available concerning your bending node files. And this is specific to the information Kieran provided as to how to actually add leaders to them, which is a great option. What I'm specifically focusing on now is for you to actually customize your bending node file to specifically see what you want to see regarding your up and down bends. So guys, to just sum this up in a nutshell, there is a specific bend node file that basically hosts your bend direction, your bend angle, and bend radius. Specific to flat patterns, of course. Where to find this node file? I'll just show you guys a quick example of it. As you guys can see, very, very straightforward. We can have multiple displays, and I can, of course, remove or add any information if need be. So basically, guys, you can really customize this to a great extent. The most default thing I've seen or coming through in support is guys actually clicking on a flat pattern, going to the property manager of that flat pattern and manually removing and adding text. This can really be strenuous, guys, as you can see on the bottom right over here. I wouldn't recommend this workflow. For minor changes, good, but you don't want to constantly on every sheet go and change this specific settings. So just to continue, guys, before we jump back into SolidWorks, very few guys actually know that there's a cut list note that's available. So what I mean with this is there's a note containing all the reference cut list properties of your sheet metal bodies. Once created, the note can actually be added, also with leaders, etc., etc. So a lot of annotations coming through. And the way you get this going is very simple. Right-click on any flat pattern view, go to annotations and hit this option stating cut list properties. So you guys can clearly see what's the effect. I'll jump into SolidWorks, demonstrate this in a moment. Moving on, I'd just like to finish this series off by going a bit into DXF exporting settings or options. So to sum this up, there are basically two options to export to DXF, guys. Most of us are familiar with the most common one, that's in drawings. You go to File, Save As, and select the DXF option. But did you know that in the part environment, right-clicking on the flat pattern gives you a very quick option to also export to DXF. No need to create a drawing. I'll quickly show you guys in a moment. And then to finish off with just a very nice finishing touch to DXFs, it's always a good idea to go and investigate what we call a custom mapping file or format. So what this means is in your settings under DXF export, we can go in and enable custom map SolidWorks to DXF. And this contains all your layer information. The good thing about this info is that it communicates cross-platform. So if you're in a 2D platform like AutoCAD or DraftSight, this information will communicate through to your DXFs and vice versa. Very, very nice color coding coming through that can represent up or down bending. So let's quickly jump into SolidWorks and show you guys what I'm on about. So the first thing I'd like to just show guys is the bending notes. This is what I'm on about. You guys can go and have a look at this text document, go and add any information, customize it, make it your own. And just to point out, you can have more than one display type. So please go and have a look at this. Please don't get accustomed or feel forced to use this. The second thing, guys, is the cut list properties. So right-clicking on a flat pattern, going to annotations, and hitting this option stating cut list properties will create a note hosting all your cut list values. So as you guys can see, nothing fancy. It's a note hosting all my cut list properties. I've seen, unfortunately, too many guys sit for hours typing this info out, and it's really not necessary. Just to show to you what is possible, we can do something like this. Just a very simple example. And I believe that can be a nice finish or addition to your sheet metal drawings. So please go and have a look at this, guys. Very simple, right-click, annotations, cut list properties. I'll be finishing off, guys, just by showing you, if I go back to the part environment. So here I've got a normal sheet metal part. Right-clicking on any face gives me the option to export to DXF DWG straight off the bat. In your flat pattern folder, clicking on any flat pattern over here will also bring those options to light. So just to show you what happens if I click on it, you'll notice the same workflow is pulled through, or the same method is pulled through, coming from the drawing side if you're more familiar with that side of doing things. Last but not least, guys, I'll finish off by just showing you quickly what I mean with or where to find the actual mapping of it. So if we go to your settings, go to export, you hit the option for your DXF DWG, you'll notice there's the option I'm on about. So enabling this allows you to go and actually select a map file that can contain all your layers regarding colors, can then definitely show the guys very quick and easy what's up and down. So thank you so much for those in attendance today. I'm pretty sure we've all learned a thing or two about a thing or two. Like Rudolf mentioned, guys, please stay tuned for our advanced sheet metal training that the dates will be applied to all of our platforms. So go and check out our YouTube and all available other social media platforms for more info. So thank you so much from my side, guys. Enjoy the rest of your afternoon. Over to you, Rudolf.
There you go. Raymond, thank you so much. Appreciate it. Raymond and Kieran, thank you for the webinar. I hope you guys enjoyed it. Thank you guys for attending. And yeah, like Raymond also mentioned, if there's any questions or you have any suggestions, please feel free to get in touch with us. You guys by now, show you guys now our email addresses, or our email is to support@mecat.co.za. So please feel free to get in touch with us. Yeah, thank you so much, guys, for attending, and have a good day. Bye-bye.